Okay, so for number 3, you need your formulas for your double angles here. Did you find all those just fine?
Yeah, I got 1 and 2 fine.
Okay, so for the first one, you should have 2 sine of I cosine of alpha. Alpha. And then if you look at number 3, notice that that has that same form, right?
Mm-hmm.
Where alpha would be 15 degrees. So I could say then 2 sine of 15 degrees times the cosine of 15 degrees would be the same thing as the sine of 2 times 15 degrees, which would be the sine of 30 degrees. And then you can say that that's using your unit circle. A half. That makes sense?
Yeah.
Okay. Do you have another question?
Yeah, number 4.
So number 4 is going to be very similar to this one, but we're going to use the second formula instead.
Okay.
Yeah, so you should have, scroll down here, that the cosine of a double angle is a bunch of formulas. The one that matches this one is the last one, 2 cosine squared of alpha minus 1. And you'll notice that that's the same thing as this when alpha is pi over 8. So then you'll do it just like number 3. You'll convert this into the original double angle, and then you should be able to use a unit circle to find what the cosine of that is.
Okay.
And that's the same trick for number 5. So number 5, you should have the tangent of double 2 alpha is 2 times the tangent of alpha over 1 minus tangent squared alpha. And again, yeah, notice that that's the same form where alpha is, again, pi over 8. So then you could say that this is really equal to that, where alpha is pi over 8. And then unit circle. Does that all make sense?
No.
No?
Less than
No.
confused.
So the idea here is really these problems 3, 4, and 5 are just getting you used to what the formulas are. So if you look, this is the right side of the equations in your formulas that you had for number 1. And when you notice that, you just have to identify the parts of this formula. Like this one, right? The only different that is from your formula is your alpha actually has a value of pi over 8. I already wrote that. So then to find the exact value, you just convert this to the left side of the formula, and it would be the cosine of 2 times pi over 8. And 2 divided by 8 is what, a fourth? And then you say, all right, so pi over 4, that's 45 degrees. What's the adjacent over the hypotenuse for a 45, 45, 90 triangle? Or really, you just pull up your unit circle and you see cosine of, or find the angle of pi over 4, and it's your x value. You should get square root of 2 over 2. That's the same trick you do for number 5. So you look at this really complicated expression, but it should seem familiar to you because for number 1, you should have that as one of your formulas as the right side of the equation. The only difference is alpha is actually plugged in as pi over 8, right? And so if you use that this is the right side, then the left side would be the tangent of 2 alpha, where alpha is pi over 8. That'll also be 2 times pi over 8. So that'll also be the tangent of pi over 4. And then you look at your unit circle, and remember when you're doing tangent, you have to do y over x. And for all of these, you can double check them with a calculator. So you could take your final answer of tangent of pi over 4, type that into your calculator and see if that's the same answer that you got using your unit circle, right? You could do the cosine of pi over 4, make sure your calculator's in radians, and it'll give you a decimal and see if that's the same thing as the square root of 2 over 2. And then you could triple check it by going back to the original and typing in that really long one and see if it's the same decimal. All of them should have the same answer if you're doing it right. Does that make a little bit more sense now?
Yeah, kind of.
It takes some practice with the formulas, yeah. Is there another one that you have a question on?
Yeah, on 10.3, I have a few.
All right, what you got on 10.3?
3.
Okay, yeah, so for this one, we're going to use this first formula where the sine of alpha over 2 is equal to the plus or minus square root of 1 minus cosine alpha over 2. So the idea here, that's not what I want to do. Beep. Okay, so the idea here for number 3, hi Lincoln, is what we can say is the sine of 15 degrees is the same thing as the sine of 30 degrees over 2. The reason why we do this little conversion here is because then it matches this form, right, where alpha is 30. All right, so then we can use the formula where this will be the plus or minus square root of 1 minus cosine of alpha, and again, alpha is 30, over 2. Now I say plus minus here, but really at this point you don't actually need to plug in the plus or minus. You should look at your angle to determine whether or not it's positive or negative. So the sine of 15 degrees, that's in the first quadrant, which means that it should be positive. If it was the sine of like 215 degrees, then that would be in the third quadrant, and in the third quadrant sine is negative, so you'd put a negative here. And then if you evaluate this, again, you just use the unit circle. The cosine of 30 is, I believe, the square root of 3 over 2. Yeah. So then this becomes the square root of 1 minus the square root of 3 over 2 over 2. And then I would probably simplify this a little bit so there's not a fraction within a fraction. And to do that, I'd multiply everything in the numerator by 2 and everything in the denominator by 2 to get the square root of 2 minus the square root of 3 over 4. And then the square root of 4 is 2. So final answer is the square root of 2 minus the square root of 3 over 2. Isn't that fun?
Oh, it's so fun.
That's a fun problem from start to end. It's just like sitting on the edge of your seat. What is it going to be? I'm so curious. Okay, number 4 is along those similar lines here, though I've already done the little hint. Notice for number 4, right, that's the same as our second one here, right? Same form, where alpha would be 5 pi over 4. So then you write the second half of your equation, right? But instead of alpha, you put 5 pi over 4. And it might be hard for you to work out in what quadrant that's in. 5 pi over 4 divided by 2 is 1.963. And pi over 2 is 1.571. So, and of course, pi is 3.14, right? So this is between these two values. So this one is in the second quadrant. And if it's in the second quadrant, then when you use your formula and it says plus or minus, you have to ask yourself, the second quadrant is cosine positive or negative. And then you won't put plus or minus, you'll put that sign. Does that make sense, or do you want to work that out a little bit more?
Can we work it out a little bit more?
Okay. All right, let's scroll down here. Okay, so you should have the formula cosine of alpha over 2 is equal to plus or minus square root of 1 plus the cosine of alpha over 2. All right, okay, so if we know this is in the second quadrant, right? 5 pi over 4 divided by 2 is in between pi over 2 and pi. So this is going to be negative, and we know alpha is this part in the numerator, 5 pi over 4. So this will be the negative square root of 1 plus the cosine of 5 pi over 4 over 2. All right, and then what is 5 pi over 4? So we look at our unit circle. Should have 5 pi over 4 is what? That's right here.
Yeah.
Has negative square root of 2 over 2, negative square root of 2 over 2. And again, the cosine is the x value here. So this becomes the negative square root of 1 minus the square root of 2 over 2 over 2. And then really the rest of this is just simplifying. Again, I don't like the fraction within a fraction, so we'll multiply the numerator by 2 to get rid of that divide by 2. And then we have to do that same thing to the denominator. So on the top, 1 times 2 is 2. The divide by 2 and multiply by 2 cancels, leaving me with just the negative square root of 2. And then in the denominator, 2 times 2 is 4. And then last thing you have to do is this denominator here is a perfect square, so you can go ahead and actually square root it and get the negative square root of 2 minus the square root of 2 in the numerator over just 2 in the denominator. Number 5 works the exact same way, except you, again, have to use the little trick that we used in number 1. What we can do is rewrite this as the tangent of 45 divided by 2. So then alpha is 45 degrees. And then I know the tangent has 3 possible formulas it could be. And you could just pick whichever one that works best for you. All right, does that make sense? Do you have any more questions? Do you want to try to work out number 5 and then I can tell you if you got it or not?
Sure. So it's the 1 minus cosine over sine, right?
Yeah, that works. Oh, this one's kind of fun to simplify. Actually, yeah, most of the struggle in this one is simplifying.
Okay, so I simplified it to 2 minus cosine square root of 2 over sine square root of 2 because I multiplied by 2 on the first equation. Is that right?
Hold on. You say for your first line?
I multiplied by 2 and I got 2 minus cosine square root of 2 over sine square root of 2.
I don't know. I don't know about that.
Well, shoot.
Maybe. Let me see. Let me write out how I have it. Because I don't think you should have sines or cosines in your problem anymore. Maybe you're just at a. So your first line should be this: 1 minus the cosine of 45 over the sine of 45, right?
Yes.
Okay, and then you should get 1 minus the square root of 2 over 2, square root of 2 over 2. And then no more sines and cosines.
Oh, okay, okay. That's where I did it.
Okay, and then here, what I don't know if there's more than one way you could go about simplifying this. You could split this into two fractions. Because if you do that, you'll notice that on the right fraction here, this right term, that's just 1. Right,
Mhm.
square root of 2 over 2 divided by square root of 2 over 2. And then over here, you do have a little bit of a problem. You're going to want to multiply by 2 to get rid of the fraction within a fraction. And you got to do that to the numerator and the denominator. And then you'll have one more problem. You'll have a square root in the denominator, which you need to rationalize by multiplying by the square root of 2 over 2. Or the square root of 2 over the square root of 2. So got multiply by 2, multiply by 2, 2 over the square root of 2. And then, yeah, multiply by the square root of 2, multiply by the square root of 2. And then after you do that, you should notice that you have 2 square roots of 2 over the square root of 4. But you can take the square root of 4, and then you'll have one more thing you can cancel out.